Okay, so let us start unit number 4. Perception, types and errors of perception. So these are the questions that you will have to look out the answers for in the upcoming slides. Differentiate between monocular and binocular cues of perception. Explain the factors responsible for movement perception. Explain the size distance invariance hypothesis, familiar size hypothesis, and the direct perception hypothesis with reference to the process of size perception. Is perception always correct? Support your view with some appropriate examples of illusions. Differentiate between illusion and hallucination. Introduction. So in the previous unit, we studied the meaning, nature and laws of perception. In this unit also, we will continue with the topic of perception. Since vision seems an effortless process, we often take this process for granted. However, in reality, the process of perceiving color, shape, form, and movement is not simple. In this unit, we'll make an attempt to solve the mystery of perceiving various types of perceptions such as depth, distance, movement, and size. Further, we will see what are various types of errors in perception and how different types of illusions affect our process of perception. We will first see perception of depth and distance. The subheading will be monocular and binocular cues. Subheading for monocular cues will be relative size, texture gradient, aerial perspective, linear perspective, interposition, accommodation. And for binocular cues, it will be retinal disparity, convergence. Then we'll see movement perception, size perception, error perception, and different types of illusion like Muller-Eyre illusion, Ponzo illusion, Ebbinghaus illusion, the Ames-Strom illusion, and Moon illusion. Right. Perception of depth and distance. So, depth perception refers to one's visual ability to perceive the world in 3 dimensions and thus enabling him to judge the distance of an object. Whereas, the process by which we determine the distance of an object is known as distance perception. It is critical for our survival and it helps us to navigate effectively around and function in the world. Without the perception of depth, it would be impossible for us to tell how far objects are from us and how much we need to cover to reach them or to avoid them. Our brain uses both monocular and binocular cues to judge depth and distance. Now, a cue simply means a signal or an indicator. In general sense, monocular cues provide deeper information about a particular scene when viewed with one eye, whereas binocular cues provide deeper information about a particular scene when viewed with both eyes. Let's see this in upcoming slides. Monocular cues are essentially the cues that allow us to see depth using just one eye, or to detect how near or far an object is in relation to our position with one eye. These are those information or cues that our brain receives from one eye only. These cues are weaker than binocular cues in strength, but there are times when we feel closing an eye may give us better judgment in the distance of an object. Let's see some of the common monocular cues in next slides. Relative size. This cue gives us information about the distance of an object based on its relative size with a similar object. This cue works on both 2-dimensional as well as 3-dimensional images. The object tends to appear small when it is further away and bigger when it is closer. This cue is a function of size of retinal image. Texture gradient. This cue is based on our perception of the change in the gradient or degree of texture. The texture of the objects which are nearer to our eyes are rough or distinct. But as you move further away from it, the texture of the object will become less distinct or smooth, and thus suggesting the perception of more distance. For example, if you look at the opposite side of the stadium that you are sitting in front of you, it seems much smoother, more blended, but if you look around at your side, you can notice the people and the other details. This change in texture correlates with distance. Aerial perspective or haze. Objects are perceived at a distance if there is a presence of haze in the environment. Haze is a result of atmospheric dust particles like fog or water vapors. Sometimes perception of distance based on haze can be deceptive. The same mountain can be perceived as nearer or at distance depending on the presence of haze. Linear perception. This cue is based on the convergence of straight lines at a point on the horizon. An appropriate example of this cue could be the perception of convergence of rail tracks at a distance. This cue suggests that closer the lines are, the greater will be the distance. Interposition or occlusion. So occlusion is nothing but closing. When two objects are overlapped, then the object which has been overlapped or obscured or hidden will be perceived as further away than the overlapping object. Accommodation. Even though this cue occurs with both eyes, it is still considered as monocular cue. It is known as accommodation because the size of our lenses accommodates themselves based on the distance. Our lenses become thicker when an object lies closer to our eyes, while it becomes thinner when an object lies at a distance. In the figure in front of you, our lenses are depicted by green color. Just place your hand over your nose and try to see it as clearly as possible. That uncomfortable feeling that you are feeling right now is your eye lens becoming thicker. Now take a look at this slide. It kind of summarizes the monocular cues that we have studied.